Okay, so let's solve this problem. So here, as you can see, so we have a combination of parallel and series circuit. The thing we have to do here is to identify how to simplify this problem. So the first thing that we can see, and I guess the most obvious, is that here these two resistors are connected in series. So remember that to calculate the total resistance of two resistors in series is just to add them. So we can say that let's call it the total resistor 1. So this is going to be the total resistor 1. This is going to be 12 ohms. So here I'm just going to erase the two resistors. The voltmeters 2, we don't need them right now. We are going to go back to them later. Right now, we just need the resistor. And remember that this is my RT1, that is 12 ohms. Now you notice here we have two resistors in parallel, and so we can calculate the total resistor. We can call this RT2, and you know that to calculate the resistance in parallel, it's 1 over RT2 equals 1 over RT1 plus 1 over the other resistor, that is 12 ohms. Okay. 1 over 12 ohms plus 1 over 12 ohms. So it's 112 plus 112, that's 1 over 6 ohms. Okay, and so that means that RT2, so it's the reciprocal, is equal to 6 ohms. The reciprocal of 1 over 6 is 6. Okay, so now we know that RT2 is 6 ohms, and again we can simplify this into a single resistance. We can calculate the total resistance of the circuit, that is these two resistors only. So because they are in series, so now we just add them. So now let's call it, we can call this RT3, not to repeat names. Okay, so it's RT3 is 2 ohms plus 6 ohms, and so the total resistance of the circuit is 8 ohms. Okay, this is my total resistance. Okay, and with the total resistance we can calculate now the amps. Okay, we can calculate the current. For that we use Ohm's law, and so remember that Ohm's law, what Ohm's law says is that the current is V over resistance. Okay, so this is the voltage, that is the battery, and R is the total resistance that we already know. So we only substitute. So we know that the voltage is 8 volts, and the total resistance is 8 ohms. So now we know that this is 1 amp. Okay, this is 1 amp, and this is this. Okay, so now we know the total value of the current. Okay, so now we can return to our original circuit to calculate the other values that are missing. So we already have A1, and now we need to calculate V1, V2, and V3. And so for that we just use Ohm's law. And so now we can write Ohm's law as, let's say, V1, that is the total current, times this resistance. Okay, so let's substitute. So then this is 1 amp times 2 ohms, and that is 2 volts. Okay, so now we know that V1 is 2 volts. Now remember that to calculate the current in parallel, we know that the total current, let's call it, let's call it IT, total current, is I1 plus I2. I1 is the current in this branch, I1, and I2 is the current in the other branch. We know that this is 1. So that means that I1 is 0.5 and I2 is 0.5. I2 is 0.5. Okay, so that means that the potential difference 2 is 0.5 times the resistance, that is 8 ohms. So this is 4. So V2 is 4 volts, and V3 is 0.5 times, so that is 2 volts. Okay, well, now you can check this on your simulator to check that the values are correct, and so you can also do that on the exam to check if you have the correct results. Just remember that in the exam you need to show me the complete procedure, the simulator is only to check that your answers are correct. I'm going to share with you a screenshot of the simulator with the results. And well, if you want me to do another video with the other circuits, just let me know, okay?